This is video 2, starting off with section 1.3, page 9. We're going to start off with slope and the definition of slope, the constant rate of change. Between the dependent and independent variables. The really important part of this is the word constant and the phrase rate of change. We'll be going back and forth with this plenty of times for you to understand it if you don't understand it yet. There are 4 types of slopes. Whenever you are trying to identify what kind of slope you have, you always have to think about a person that's moving from left to right. In this case, if the person is moving left to right, they were going uphill. This is a positive slope. This would be a negative slope. This would be zero slope. It's supposed to be a perfectly horizontal line. And this we call undefined slope. At no time would you ever identify a slope as no slope, because that doesn't really mean anything in terms of zero or undefined slope. It's really ambiguous when anybody defines a slope as no slope, so you should never say that. We have a mnemonic that we like to use whenever we're trying to find the slope of a graph, and the mnemonic is the phrase rise over run. We like to put a little fraction bar over there. Whenever you're trying to find the slope of something that's graphed, what you're looking for is a number. And depending on what the graph looks like, that's how you know if the number should be positive or negative or zero. So let's look at this first one so I can explain how this works. You're going to start by finding 2 points that fall perfectly on the grid lines. I'm going to choose this point here and this point here. When I say perfectly on the grid lines, I'm talking about points that fall perfectly on the intersection of grid lines where the ordered pairs are very easy to identify, rather than something that falls in a strange, ambiguous spot. What I'm going to do is I'm actually going to draw how much I need to rise and how much I need to run if it's backwards or forwards. In this case, I'm going to rise 1, 2, 3, 4, 5, 6 units. And then I'm going to run 1, 2, 3 units, but I'm running backwards, so my 3 is going to be negative. If I'm going back to that mnemonic, rise over run, I can replace rise with the number 6 and the run with the number 3, giving this a slope of negative 2. Not a surprise that this is a negative slope, because we've already learned that if it's going downhill, it's negative. Going to this next one, I'm going to pick 2 points that fall in the perfect intersection of grid lines, and I'm going to calculate how much I rise and how much I run. I'm rising up 1 unit, and I am running 1 unit in the positive direction. My slope here is 1. And again, this is going uphill, positive number. Also want you to notice that because my slope is rise 1, run 1, if I'm on the line and I rise 1 and run 1 again, I should be back on the line. Rise 1, run 1, back on the line. This is where that term constant from the definition of slope kind of comes into play. This slope for this line is constantly going to be 1. If you had chosen 2 points that were not right next to each other, in this case, if I rise 3 and run 3, notice that it will still bring me back to my original slope of 1. On this graph, I'm picking 2 points perfectly on the grid lines. Notice that the units on the x and the y-axis jump by 2s. So if I were to rise here, I'm rising 4 units, and I am running 2. So my rise is 4, my run is 2. The slope of this line is a positive 2. The y-intercept is the place where the graph function touches the y-axis, identified as an ordered pair. The x-intercept is the place where the graph function touches the x-axis, also identified as an ordered pair. Page 10 has an example at the top. What I want you to do is I want you to pause the video and answer all of the questions so that you are able to come back and check your answers with mine. So pause the video now. Okay, for A, if you're finding the slope of a line, you're going to go ahead and mark 2 points that are perfectly on the grid lines. This looks like a rise of 1 and a run of 2. So your slope of this line is going to be 1 over 2. Because this has a positive slope, we would say that this line is increasing. The x-axis or the x-intercept happens here. This is at -4, 0. You have to identify it as an ordered pair. The y-intercept is here, which is 0, 2. A linear equation in slope-intercept form looks like y equals mx plus b. Let me get rid of this. Try to get rid of it. We'll see. Let's take that down there. If the line is in slope-intercept form, that means that the letter M is going to represent your slope, and the letter B is going to represent your y-intercept. The y and the x are placeholders for the independent and dependent variable. Just so you know, x is what we call the independent variable or the input. Y is the dependent variable or the output. And so whenever you see an equation of line, you'll always see the x and the y always there, and then there'll be numbers in the spot for M and the spot for B. So for instance, if I look at A and I'm trying to identify the slope and the y-intercept, the slope, notice, is always paired up with the x, the independent variable. So the slope for A is 2. The y-intercept is the ordered pair 0, -4. Again, the slope is 2, and the y-intercept is 0, -4. For B, I have -1/3 next to the x. That's the slope. The y-intercept is going to be 0, 1. For C, I have a slope of 2. The y-intercept isn't written as clearly as the other ones, but I could draw it in there if I wanted to. If you don't have a number there, you can assume this goes through the origin, 0, 0. For D, the slope is 1. Some people will say it's 0, but it's not. If there's no number written in front of x, you can assume that number is 1, and the y-intercept is 0, 10. And for E, we don't have an x on there, so I could rewrite this as 0 times x plus 6, meaning the slope is 0 and the y-intercept is 0, 6. Remember, when you have a 0 slope, if you're drawing the line, it just looks like a flat horizontal line. That is what a 0 slope looks like. Page 11. On this page, we're going to look at graphing lines. The first step always when you're graphing a line is to make sure that the line is in slope-intercept form. That is y equals mx plus b. It has to be in that form. You can't interpret the slope and the y-intercept unless your line looks like this, y equals mx plus b. So I'm looking at this first one, and I'm identifying that the slope is 2, and the y-intercept is 0, -1. My second step here says to plot the y-intercept. So I'm starting at the origin. I'm counting 1 unit in the negative direction. That's the y-intercept. And then I'm going to use rise over run to plot the points for the rest of the line. So remember, if the slope is 2 and I want to make that a fraction, that would be rise 2, run 1. I have to start at my y-intercept. I'm going to change the color of my pen to red, and I'm starting at the y-intercept. I'm going to rise 2, run 1, make a point, rise 2, run 1, make a point, rise 2, run 1, make a point. It's probably best if you try to make as many points as you possibly can to make an accurate line. Using your straight edge, you're going to go ahead and connect the points. Let's see here. And then you're going to put arrows and label it. Every time it's pretty much the same procedure. Plot the y-intercept. In this case, it's 0, 4. 1, 2, 3, 4. And then plot the slope. Starting at the y-intercept, I'm rising 1, running 1, rising 1, running 1. And then I'm going to draw my line, put my arrows, and label it. You always have to start with a y-intercept first because you need a place to start for rising and running. You can't just rise and run anywhere and have an accurate line. You have to know exactly one spot where the line is so you can use that constant rate of change to plot more points. For number 2, my y-intercept is the origin, 0, rise 3, run 4. I'm only able to draw 2 points. Hopefully I'm going to be able to freehand actually no, I can use this piece of paper right here for my straight edge. And then maybe it'll look better than the last couple of them. Drives me crazy when I have lines that are not straight. Oh, that's beautiful. Y equals 3 over 4x. The last one, my y-intercept is going to be 0, 2. That's right here. And I'm going to rise 1, run 2. And I'm going to go ahead and do my best to try to connect those dots and label my line appropriately. All of these slopes happen to be positive slopes. So now we need to look and see what happens when you have a negative slope. So for number 5, I have a negative slope. It's negative 2/3. My y-intercept is 2, so I start at the origin, go up 2 spots, make a point. Now when you have a negative slope, you can do one of 2 things. You can put the negative symbol with the numerator, or you can write it with the negative in the denominator. I just want you to know these are equal, and they're also equal to the negative just being right out front. If I were to use this second one, I would start at this point and rise 2 and run negative 3 and make a point. That's using this version. If I use this one, starting at my my y-intercept, I'm rising negative 2, which is not really a rise. It's more like a fall. We're going to fall negative 2, run positive 3. Notice that either or, both of those will end up giving you the same line. Just depends what you're limited to with your graph paper. Y equals negative 2/3 x plus 2. It's a downhill line, not a surprise because it's a negative number. I want you to take a moment and do number 6 and 7. Go ahead and pause the video, and then I'll go over it with you in just a minute. So for number 6, my y-intercept is negative 3. My slope is rise 1, run 3. There it is. I can only make 1 point with the limitations I have with my graph. Draw, arrow, label. For this last one, I have a slope of -2, so I can express that one of two ways. I'm going to start at the origin and go up 5 units and make a point. I'm going to have to fall to and run +1 because I cannot rise to because I'm limited with my graph. So I'm going to have to use this one. Rise -2, run 1. Rise -2, run 1. -2, 1. There is my line. You can tell that all of those points are collinear. Collinear means that the points fall in the same line. You can't use collinear if you have a graph that has a curve. Collinear is only a word used for lines. There's our label. Okay, so here's a couple examples where you're asked to interpret and find the slope and the y-intercept, and your linear equations are not in the proper form. So remember that anytime you want to interpret it, you have to have your linear equation in slope-intercept form. This one I can do that if I subtract 2x from both sides. I'm actually going to be crafty here and put my -2x in the front and push the 12 in the back so it looks beautiful, just like my thing up here. If you did write this as y equals 12 minus 2x, you're not wrong, but it's a little bit more confusing, so I try to make it look the way that I'm used to seeing linear equations. The slope for this line is -2. The y-intercept is 0, 12. For the next one, I'm going to be super crafty here. I don't want my y to be negative, so I'm going to actually add y to both sides. So I have 3 equals 1/2 x plus y. Then I'm going to subtract 1/2 x from both sides. That will give me y equals -1/2 x plus 3. -1/2 is my slope. 0, 3 is my y-intercept. Okay, so let's talk about finding the slope of a line that goes through 2 points. So we're going to look more at an algebraic approach, not as much a visual approach like what we have been. This is our handy dandy formula. This actually is usually referred to as delta y over delta x. And delta is a triangle. It's a Greek symbol. It means change. Change in y over change in x. Basically, what you're going to be doing is if you have 2 ordered pairs, you're going to be able to plug the numbers from the y coordinates over the numbers from the x coordinates to come up with the number that represents the slope. So let's look at A. We're going to find the slope of a line that goes through points 3, -4, and 2, 1. I'm just going to take one of these, it doesn't matter which one, and make it my x1, y1. And I'm going to take another one of these, and I'm going to call it my x2, y2. That way I have everything nice and tidy. And I'm going to go ahead and draw my my delta y over delta x. y1 minus y2 over x1 minus x2. I'm going to make sure that I have all of my pieces together that I want to have there. My y1 is -4, so I'm going to put that here. My y2 is 1, so I'm going to put that here. My x1 is 3. My x2 is 2. Oh my goodness, all of these things. Notice that if I chose 3 and -4 as this is my number 1 ordered pair, that ordered pair leads off on the top and the bottom. And whatever I used as my second ordered pair, that will be on the tail end of the top and bottom. So you can't interchange them halfway. You have to stick with it the whole way. Once I simplify this, -4 combined with a -1 is -5. 3 minus 2 is 1. So the slope for this line is -5. Remember that you cannot change this symbol to a positive symbol. That only would happen if you had 2 negatives with nothing in between, like an example like this, that is when you would change this to positive and have a positive outcome, but this is not the case. Just a little bit of a refresher. Let's look at B. Find the slope of the line represented by the following table. You only need 2 ordered pairs. This is giving you 5, so you get choices here. I'm just going to pick 2 of them. I'll pick 1, 7 and 5, 9. And I'm going to use my delta y over delta x. Does not matter, again, which one you make your number 1 and which one you make your number 2. What does matter is that you are being consistent with what you're choosing to put and where. For instance, if I make this my x1, y1, and I make this my x2, y2, that's okay. It doesn't have to be the first one is 1. You can, just as long as you pick one of them as your number 1 and one as your number 2 and be consistent. So my y1 is 9, my y2 is 7, my x1 is 5, my x2 is 1, and so my ordered pair, my slope is going to be 9 minus 7, which is 2, over 5 minus 1, which is 4. The slope for this line is 1/2.